Hello, I'm Geneva Bowling, and in this video I'll be presenting my Lab 4 Oscillations report. The purpose of this lab is to examine the motion of the spring mass system in which the mass swings in an arch while also oscillating on the spring. Our goal is to determine whether the model follows the energy principle. As a result, the system's total energy remains constant at zero, thus demonstrating the energy principle. For fundamental principles, we use Newton's second law and energy principle, which tells us the system's change in energy is the sum of work done by surroundings and thermal energy Q exchanged with the surroundings. Our system is mass, spring, and earth, and surroundings is none. Useful equations we use is the velocity and position update formula, kinetic energy, gravitational potential, and spring potential energy formula. Our initial conditions, our object's mass is 0.402 kilograms. Our state equilibrium distance is at 0.70 meters. Initial position is at negative 2.027 meters at the x direction, negative 1.303 meters on the y direction, and our initial velocity is 0 meters per second. For finding our spring constant and relaxed length of spring, we use our graph at the x direction to find period at t1 to t3 and solve t. We use that t to solve our spring constant using the formula of the time period of a mass spring system, which is 6.875 newtons per meter, and from there we use k to find our relaxed length of spring, which is 0.127 meters. In GlowScript, we set our initial condition from what we obtained beforehand. From line 88 to 90, we use Hooke's law for our spring's length, and on line 93 to 96, we use the energy principle, which contains kinetic, gravitational potential, and spring potential energy. Under our while loop, this is our motion prediction. We first set our initial energies and then calculate Fnet, which will help us find the object's velocity and position. We also calculated our spring's length and energies to see the changes throughout a period of time. Under possible errors, I have that in reality no system is isolated from their surroundings, so there is work done from the surroundings. And secondly, human error, like placement of center of mass and tracker, can make the experiment inaccurate. Is the energy principle satisfied? Yes, since no external forces affected the isolated system, the change in energy must be zero. Even though there's different types of energy in the system, the graph shows that the total change in energy is constantly zero. To find our oscillating periods in the x and y direction, we use the same method of finding our time period using the graph, which are already different. Furthermore, when solving k, we can see that they have different spring constants.